In this module, we will look at solving various exponential equations. The way to solve these equations is quite simple. We aim to reduce both sides of the equal sign so that each base is exactly the same. So in this case, it's clear that the simplest base, will be the number 2. We reduce then 4 to 2 squared, so the left-hand side becomes 2 to the power of 2x, and the right-hand side becomes 2 to the 4x. Now if the bases are the same, then clearly the powers must be the same. So 2x must be equal to 4, therefore x must be equal to 4 divided by 2, which is equal to 2. To test that you understand how to solve these types of simple exponential equations, try and do the following two examples by yourself. The answer to both 1a and b will be given at the end of this slideshow. Let us look at a slightly more complicated problem. In this case now what we have is we have the usual exponential expression, but now it's multiplied by a constant. Now in this case what we do to solve is we first divide both sides by the value of the constant. So in this case it will become 25 to the power of x is equal to 375 divided by 3, which is equal to 125. As in the previous example, we now reduce the left and right hand sides of the equal sign to its simplest prime number base, so it will become the left hand side 5 to the 2x, and our right hand side is 5 to the power of 3. Now again, if the bases are the same, it means that the powers will be the same. So 2x will equal 3, therefore x will equal 3 over 2. Again, to test that you understand how to solve an exponential that is multiplied by a constant, try to solve the following two examples by yourself. In a slightly more complicated exponential equation, we now have this type where we have an exponential multiplied by a constant, and then we add a second term, and that's going to be equal to 1718. In this case, the first thing we do is we get rid of the second term after the exponential equation, the exponential expression on the left-hand side of the equation. So in this case, we subtract 3 from both sides, so we'll get 5 times 49 to the power of x is equal to 1715. Now we divide both sides by 5. We'll have then 49 to the x is equal to 343. What we now do again is we reduce each side to its simplest base. So 49 is 7 squared, so it becomes 7 to the 2x, and that is equal to 7 to the power of 3. So then we'll have the two bases are the same, therefore the powers must be equal. So 2 to the x, 2x will equal 3, therefore x is equal to 3 over 2. Again, to test that you understand how to solve these more complicated expressions, attempt the two homework problems by yourself. When attempting to solve these exponential equations, remember, first get rid of the expression that is added or subtracted, and then divide both sides by the constant that is multiplied to your exponential component. The fourth kind of exponential equation combines all the possible combinations in one sum. So again here what we do is we first try to get rid of the expression or the term that is subtracted. So in this case we will add 13 to both sides. So it'll become 5 times 27 to the power of a third x plus 2 is equal to 405. Now we're going to divide both sides by 5. So we'll have 27 to the power of a third x plus 2 is equal to 81. Now we're going to reduce each of the bases to its simplest prime number. So 27 is 3 to the 3. So 3 to the 3, and we're multiplying one step out into the brackets. So it's going to become 3 to the x plus 6, because 3 multiplied by a third is 1, and 3 times 2 is 6. And 81 is 3 to the power of 4. So we have x plus 6 is equal to 4. That's because the two bases are equal. And solving that equation, we will have x is equal to minus 2. To make sure that you understand how to solve these equations, do the homework on the next page. After completing these two examples, you can then go to the final slide to check your answers. If I and you haven't made any mistakes, then these should be the correct answers to the homework in this module.